In this session, we will start with the continuous probability distributions, and particularly in this session, we will talk about the uniform distribution. The continuous probability distributions are based on uncountable continuous variables like, for example, the lifespan of electronic devices, the weight of manufactured parts, acidity level of liquids, the weights of the newborns, etc. The idea is, as you see, those are strictly not discrete variables, so they're continuous. So we will use continuous variables to make operations over them. And different types of curves for different variables can present. For example, the sugar level in blood, or time passed until a drug gets ineffective, etc. They can have different type of distributions. The most basic one, or maybe the most common one, is the uniform distribution. It's like picking a random number in a given range. Now let's try to explain this to you. Let's take a look at this together. So suppose that we have a random number y, here, okay, y, and suppose that it is between a and b. So this is called now a continuous random variable in this sense. So what you have here as probability is something like this, because each one of them should be equal. 1 over b minus a for each of them, where your y is between a and b. So if you want to show it in a graph, something, so this is your y, and what you have here will be your a and b, and the thing is, it will look like this. What you have here will look like this, and that should be what? 1 over b minus a. B minus a is the probability of this function. And what should be the expected value of y here in this sense? And it is also, that would be your population average as well. And this is what you're expecting if you make a lot of trials here. This is what you're going to expect. And what would be the variance of this distribution, which is your this one, square of your standard deviation. It would be b minus a square over 12 is its variance here. And if you're curious about a particular range here, the probability of, for example, x being between c and d here, if you're curious about a range here, that's what we're trying to address. It would be equal to what? D minus c over b minus a. I think that's very, very convenient to take note. Okay, now let's take a look at an example here from our textbook. We're talking about thickness of plates produced at a factory. Okay, thickness of plates produced at a factory here, and they're within 150 millimeters and 200 millimeters range for that thickness. But when the plates are produced under 160 millimeters, any thickness less than 160 millimeters will be discarded or remanufactured. Remanufacture required. It means that they are unacceptable, okay? So the first part of the question is asking us to calculate the average thickness of this production facility and its standard deviation as well. These are being asked to us, and let's start with the average first, or the expected value. Okay, see the minimum and maximum amounts are given here. You add them up and divide by 2, and you can see that 175 millimeters is your average. And what about the standard deviation? In this sense, the formula for the variance was b minus a square over 12, right? So when you put the numbers in their positions, since you have a calculator, it's 50 square over 12, and that would be something like 208.33. And when you take the square root of this one, the sigma should be 14.43. Now this time I can place a unit here since it is standard deviation, and the answers to your part A will be this one for the average and this one for your standard deviation. Now the second part of the question is asking us to calculate what is the probability of remanufacture. What is the probability of remanufacture? If we return to our question, any thickness less than 160 millimeters will require remanufacture. So what we're trying to calculate is the suppose that is 150, 160 or something like this. We're roughly trying to calculate this area over 1, like a probability like this. And so the probability of y less than 160 is what? So like this should be your minimum value here, and what you have here will be given in the question as well. And your minimum is, of course, 150, and the result is 1 over 5, which tells us that there is 20% remanufacture probability for produced plates in this factory. So that will be your answer. And this is briefly about the uniform, this how we use the uniform distribution. Thank you for listening.